So let's work on page 266, example 3. We're dealing with Newton's method. Let's solve this question. So what we have here is we're solving cosine x is equals to x, and please have the algebraic know-how to throw one side over. We have cosine x minus x is the function f of x we're interested in solving, and you solve it when that function equals 0. That happens to be the x-intercept. So f of x equals that function here. Find the derivative is a good pattern to know because we need the derivative and the original function in the formula. So once you have the formula, this becomes very mechanical. This Newton's method gives us a better guess. So if you have no initial guess, you can always do a rough sketch using your pre-calculus knowledge. Cosine starts high and goes low. You know that cosine, half of the cosine period ends up at pi here, and then you know that 2 pi, it ends up back up there. Y cos x is a basic line equation. And you can see that as long as you sketch this roughly right, this is 1, 2, 1, 2, 3, 3.14, pi is slightly past it. We're hitting a little bit less than 1. So why don't we let our first guess for the solution for the x-intercept to be 1. So we're going to set our first guess x1 to be 1, and therefore the next guess x to the n plus 1 happens to be x2. When we set n equals 1, here's our formula. So plug in that first guess 1, and make sure you're in radian mode. Cosine of 1, 1, 1, 1. Just plug it all in. Make sure you're in radian mode, not degree mode. And we're going to get our first guess. It's going to be about 0.75-ish. And like we explained previously, you just keep on using Newton's method, storing this value into your calculator, and you're going to get an x3 guess once you set n equals 2. And this pattern continues. Okay, so using the same Newton's method formula, you figure out x4, x5, and you realize they match pretty well. Now the question is asking for correct 6 digits. Now if you count these first 6 decimal numbers and these first 6 decimal numbers, you realize that they're the same. Make sure that you round the last digit properly. It rounds down to a 5. So we have, therefore, 0.739085 is the correct root